Okay, I want to start this when we talk about exponential functions by looking at this. And what I did is I used Desmos. If you guys haven't ever used that, it's kind of fun. You can't use it on a test, but it's kind of fun to see what your graph would look like, and you can kind of mess with it. But what I'm wanting to show you this is these are all exponential. I didn't mean to move that. These are all exponential functions right here. And it's because the x is the exponent. But what I want you to see is they all look basically the same, except they just go up a little steeper. Okay, so notice in the red one, my base is y equals 2 to the x, but compare it to the green one where it's y equals 5 to the x, and this one's got a bigger base, it's just going up a little steeper. Okay, so they all look the same. Every exponential graph has this look, okay? Notice they all go through this point right here. This is all called the parent graph. It's the point 0, 1. And the reason that is do you realize that 5 to the 0 is 1? Or 3 to the 0 is 1? Or 10 to the 0 is 1? Okay? And we're going to eventually talk about this little value e. E is a number, kind of like pi is a number. If you hit it in your calculator, it's about 2.718. But we'll get to that later. But even e to the 0 is 1. So that's probably a good thing to know if you didn't realize that. Also, let me change my color real quick right here. Let's go here to like maybe orange. Notice all of these graphs, if I would zoom in, and I can't zoom in because I'm not on my Desmos graphs, it looks like they're hitting 0, but they're not. They're getting super, super, super close to 0. So when your graph gets super close to something and approaches it, it's called an asymptote. Okay, so an asymptote, I always say it's an imaginary line that your graph is approaching. So in this case, the equation of this line right here, you're like, that's the x-axis. It sure is. But the equation of that line is y equals 0. Okay, so for example, if I wanted, let's do a different color here. Let's do boring brown. This equation of this line, if it's a horizontal line, notice it's going through 10. Oops, pretend that's horizontal. That would be the line y equals 10. Okay, so that's probably a good thing to know. So something else, let's go to another page here. Okay, hopefully you can hit in your calculator just 2 to the negative 5th and come up with its decimal. If not, you might want to email me and ask me or get a calculator that'll do that. If you don't realize it, I know on my calculator it will turn this into a fraction, and then I have a little button that will then change it to the decimal, okay? But what I want you to see here is these numbers are getting smaller and smaller. Okay, they're approaching negative infinity, if you want to say. I'm going to put in 2 to the negative 10 real quick in my calculator and see what it gives me as a decimal. Ew, gross. It gives me 0.000976. Okay, and it keeps going on, blah, blah, blah. Okay, so what I want you to see is it's getting close to 0, but it's not 0. And this is only negative 10. So your calculator are going to get to the point where you can't handle it, but I could even put like in 2 to the negative 20, and let's see what I get. I did it real quick. So again, so close to 0, but not 0. So that means that my asymptote is my graph is getting closer and closer to 0. So my asymptote would be the line y equals 0. Okay, now let's look at some of these graphs. Okay, what about this one? So let's look at this. First of all, see how this is an after the fact? This tells me that my graph is going to go down 4. I mean, I already know that, so I've got a visual. This right here is called my parent graph. We just looked at what every exponential graph looks like before you start messing with it. So I'll just go ahead and do this one in green. It's going to look like this. Okay, we always know it goes to this point right here at parent graph, 0, 1, and it goes up exponentially, which means it goes up really fast. So it looks something like this. And I know on this side it approaches 0, but it doesn't ever touch it. So there's my parent graph. So what I'm doing is I'm going to take this and go down 4. So I can sketch this out real quick. So I'm starting here. You can't see where I'm at. I'm starting there, and I'm going to go down 4. So I'm 1, 2, 3, 4. So it looks like this. So without even plotting any points, I know it's going to go up really fast, and then instead of approaching 0, it's actually going to approach negative 4. Now, if you're like, oh, how do I know that? Okay, I tell people plug in some big negative number or plug in something. So plug in a big positive and a big negative. So here's what we're going to do. Remember, here's your function. You have a calculator. Learn to use your calculator. You remember these little T-charts? I want you to plug in a big positive and a big negative. Now let's not go too crazy. Let's just try 5 and -5. So try putting that in your calculator real quick. I'm going to do it too, so just one moment. Okay, all I did was 5 and -5, and look at a +5. Look how big that value of y is. Gosh, because he's shooting up fast. I probably should have done it more like this, actually, because, I mean, he is going up exponentially so fast. But look what happened when I plugged in just -5. -5's not even, that's not even very big. But notice it's getting really close to -4. That's because this line right here, this dotted line, that's my asymptote. Okay? So when it asks you the asymptote, it is the line. You wouldn't say -5. A horizontal line is always y equals, notice it's hitting the y-axis, -5. Okay, now let's talk about domain and range. Your domain is anything that you can plug into your function. It is your x values. It's also how far to the left and the right, like how wide is your graph. Notice there's no stopping this. It's going off to the left here. So I know it's shooting off to -infinity, and there's nothing stopping it over on the right. So my domain, I can put in anything I want. My domain is -infinity to infinity, all real numbers. But my range, let's talk about the range. And I'm going to try to find a different color here. I'll do my range in brown. My range is how high and how low it goes, okay? Well, notice there's like this brick wall down here on your asymptote. It never goes any lower than, what was it, 4, -4. So my range is -4. It's a parenthesis because it's not going to touch -4. And then it shoots up to infinity. So my range is -4 to infinity. Now, let's try another one. Okay, let's look at this one real quick. I went ahead and in green, I went ahead and put the parent function in, rough, okay? It's also, don't, go look at Desmos, but make sure I would try it on your, by yourself first, then put it into Desmos, okay? But remember, right here, if it messes with the x, it messes with your mind. You would think it goes left 4, but it does the opposite. It's actually going to go right 4. So I always start with this standard point when I'm moving it, that 0, 1 on the parent, and I'm going to go right 4. 1, 2, 3, 4. You can't see me counting, but you guys can count. So it's this graph shifted to the right 4. So it's going to look like this. Now, we're not going to take time to plug in points, but that's what it would look like. My domain, and I'm just going to tell you this, your domain on all exponential functions is always all real numbers, -infinity to +infinity. My range is how high and how low it goes. Notice it's approaching this line right here, okay? So my range is 0, and then it shoots up to infinity, and it's approaching that line, so my asymptote is the line y equals 0. I make you on the test graph it, so you just graph the asymptote as a dotted line like this. And that's what the asymptote looks like. Let's try another one. Okay, once again in green, I put my parent graph. And I want to remind you, it's going to look the same no matter what this is called your base. I don't care if your base is an E or a 10 or a 5 or a 2. They all look the same. Okay, they just go up steeper depending on the base. Okay, remember this guy makes it go up 4. So I'm going to take this graph and I'm going to shift it up 4. And this one, if it messes with the x, it messes with your mind, it's going to make it go left 2. Okay, so remember, I'm going to start with this point 0, 1. That's kind of how I get started. I'm going to go ahead and go left 2. So here's 1, 2, and then I'm going to go up 4. So from this point, 1, 2, 3, 4. So here's my new point right there. This point right here got shifted up to right there. Okay, now I'm going to clean that up. Okay, so what does this graph look like? I know from here it shoots up, and then it's going to approach right here. And remember, your asymptote was this line y equals 0, but it went up 4. So now my asymptote is this line right here. I'm going to graph it as a dotted line. And what is that line? It's the line y equals 4. Again, if you're not sure, you're going to go in there and you're going to plug in values for x. I always say try -5 and a +5. Make sure it looks good. Okay, so that's simple enough. And if I wanted the y-intercept, I noticed sometimes they might ask you that. Do you remember how you find the y-intercept? You plug in 0 for x. So you take your graph right here, and for your x, you're going to plug in 0. This is how you'd find your y-intercept. Notice that's what? 3 squared, which is 9. 9 plus 4 is 13. So my y-intercept would be the point 0, 13. I just sketched mine in. I'm sure that's not 0, 13, but my graph runs out of room. But that would be my y-intercept. Okay, let's talk about domain and range. And this right here is your asymptote. My domain, we've already talked this, all real numbers. There's no like wall stopping it. My range, well look, there's this asymptote. It can't go below the asymptote. It's not even touching the asymptote. So it's from 4 and then it shoots up to infinity. So that would be my range. All right, let's try a more interesting one. Okay, let's try this one where we got this negative out here, which is going to make it reflect. It makes it reflect actually across the y. So I went ahead, hopefully you've watched this enough to know that the green one is the parent function, okay, before we started any shifting around. So what this negative out there makes it do is I still have that point right there, and I'm not going to plot points because we're just doing a visual, but it just reflects it across the y. So it'd be like if I could fold the paper down that with the y-axis, and it would just make a nice mirror image. Okay, so that's what it looks like. Well, then what does it do? Then it goes down 2. So start with this point right here. That's just the one I work with, and go down 2. So it would be right here. Okay, so it's that same shape as the red one, but it's going to go down 2. So instead of my line approaching 0, I know it's going to be approaching -2, which is right here. This is my asymptote, because my asymptote was 0 and it went down 2. So I'm going to go ahead and put that in right there. So then my graph just looks like this. It's going to hug my ass and dope. So there's my graph. Looks just like that, okay? If you want to plot in exact points, do, but that would be the rough sketch, so you can just find it. So here's your asymptote. My domain, do you remember? My domain is always all real numbers on an exponential function. There's nothing on the left, nothing on the right stopping it. But my range, notice it can't go below. It's approaching this asymptote, but it can't go below it. So it's going to be -2, and then it shoots up to infinity. Okay, so that's my domain and range. Another one. All right, I've already got my parent graph in there, so I can start shifting it. I noticed you had one like this on your homework. I don't like my 2 written out there. I always feel like that's like confuses people, so I'm going to move him over. So notice in front of the 3 is a negative. This is a +2. So I'm just going to write him back there because I think that's the way you guys are used to seeing it, because I know that's screaming up to. Okay, I know this -5, since it's messing with the x, it messes with your mind. I know that tells me it's going to go right 5. Ooh, but look, there's a negative out front. If there's a negative out front, that tells me it's going to flip upside down. A technical term would be it's going to reflect across the x axis right there, okay? So when we do order of operations, we always know, okay, we're going to first do exponents first. And it tells me to go right 5. So I'm going to start with this guy right here. Okay, and so I'm going to shift him up. So he's still going up really fast. He's still going to approach 0. That's all I did right there is went right 5. Okay, now I'll do this one in brown. Now we're going to reflect across the x. Realize this point right here, that is the point 5, 1. Okay, if I reflect it across the x-axis, it's going to be right there at that point 5, -1. Okay, and instead of it shooting up, it's going to shoot down fast, and it's still going to approach 0. So it looks just like that. So notice I reflected it across the x. Now, okay, lovely order operations, I'm going to do up to. So I still start at this magic point right there. My magic point is shifted, and I'm going to go up to 1, 2. So it's going to look just like that. Okay, so again, it's still going down 2. But remember, it was approaching this line. Now it's approaching the line right here. I don't know if you've realized this yet, but let me see if I can pull out a different color. This guy, if there's adding nothing, my asymptote is 0. I'm adding 2, so my asymptote is the line y = 2. Isn't that cool? So it goes just like that. So my domain, what's your domain? Always all real numbers. Any exponential function. You can plug in anything you want. Your range, now this is the first time we've had this tricky part. Notice he's shooting down to -infinity, but he can only go up as high as this asymptote. So your range is -infinity to 2. Okay, I think you had one like this in your homework. I am going to start this by rewriting it. Remember, if it's got this number, I'm going to put him on the other end. So this is what I have first. Negative 1/2 to the x. That's a positive 3, so I'm going to write him at the end. That way you can see it's plus 3. Now, if I've got a fraction here, gross, I think I would prefer to write it like this, negative. And remember, I can flip that and write that as this. Okay? Remember, if you had an exponent, that's saying this, 2 to the negative, like 1x. Let's just ignore it. That's the same thing as 1 over 2. So that's why I wrote it like that. You do not have to write it like that, but what you need to realize is that if you have a fraction, if this guy right here is less than 1, it's going to end up reflecting over the y-axis. Because remember, this up here, when it messes with your x, okay, messes with your mind, that tells me it reflects over the y. This one right here tells me it reflects over the x. Gross, right? And this one right here tells me it's going to go up 3. Now, your parent right here, your parent graph, I changed your base all of a sudden, but your parent graph is 2 to the x. So what does that look like? Same thing. I'll sketch it in real quick. Okay, so the green one is my parent graph. Notice it looks just the same. This, by the way, my asymptote, it should look more like that. It doesn't, it never hits the x-axis. Okay, the parent graph. Okay, so let's just get started. Remember, we do exponents first. If, and I will do this one in blue, if it reflects over the y, it looks like this. Now, I'm just sketching this in super fast. That's what it means to reflect over the y, okay? Now, it's flipping upside down. It's reflecting across the y. So, it's going to be right here, okay? So, instead of shooting up, it's shooting down. It's still going right here. So there's that one, okay? Now we want to take that and go up 3. Blech. So I'm going to do this one in red, but I'm going to start here. I'm going to go up 3. 1, 2, 3. So we're right there. Do you remember? That's my asymptote. So it's approaching the line y equals 3, which is right here. So do your asymptotes. If you're graphing this by hand on your test, which you will be, right? I want that to look like this, y equals 3. That's my asymptote. At least you will on your final. So it's going to look like this and down. Okay? Now, again, if you're not sure, use your original one, plug it in your calculator just like that. I would put in a -5 and a +5. And let's do that just for kicks. Let's try it, and you try it in your calculator and see if it works. So what am I doing? Go back, and I'm going to use this in purple. Go back to this guy right here. Y equals 3 minus 1/2 x. Use that. Practice plugging that in. We're going to plug in 0. We're going to plug in -5 and +5. So I'm going to pause just a minute, plug those in, see what you get. All right. Hopefully you got this. If not, pause. Truly, trust me, practice getting this in your calculator. I can send you a picture of the calculator I use. It's not expensive, super easy to use. This one, you should have been able to do it mentally. Because remember, if you plug it in right here, anything to 0 power is 1, and 3 minus 1 would give you a 2. And I can see that. Look at your red graph right here. Look, that is the point. I just circled it in brown right here. That is the point 0.02, so that's awesome. But I can see on the left, -5, it's shooting down, which I've got my graph shooting down. And a +5, notice it's getting really close to 3, but it's not. Okay, so here's my asymptote. My domain is always all real numbers. There's no limits, okay? Then my range is how high and how low does it go? Well, look, it's shooting. Here it is in brown. It's shooting down, down, down. So it's shooting down to -infinity. And then it doesn't get any higher than my asymptote. So it doesn't touch the asymptote. It just gets really close to it. So that's my domain and range there. I think that's it, guys.